Okay, I'm going to be reviewing worksheet 4. That's basically the review for most of the unit, and I'm going to be doing the evens, because I assigned the odds in class. So as I go through this, if you want to follow along and you don't have worksheet 4, go to the website, go to unit 8, go to stoichiometry there, and download worksheet 4, and you can follow along there. So here we go. Question 2 from that worksheet. In a single displacement reaction, magnesium metal reacts with hydrochloric acid to produce magnesium chloride and hydrogen gas. Hydrogen's diatomic. Magnesium's a 2+ ion. Chlorine's a negative ion. So that's why I had to balance the formula as I did. So before we get too far, let's balance the equation. I need to put a 2 out in front of the HCl. And then I think everything is balanced at that point. So now let's go into our BCA chart here, before, change, and after, and figure out what we need to find from this question. The question's asking how many moles of hydrochloric acid are needed. So I'm going to be searching for this box here, the before value for HCl. How many moles of hydrochloric acid are needed to completely react with 2.43 grams of magnesium? So I'm going to be given 2.43 grams of magnesium. I need to convert that into moles to put it into my chart. So 24 grams is in 1 mole for magnesium. So this is going to be equal to 0.1 moles. So that's the value I'll put into my chart here, 0.1. And since the mole ratio values, this is a mole ratio of 1 to 2. So this value here is going to be 0.2 that I need. And that's the whole question it's asking for. It's asking for moles, so this is the value I'm looking for. Question 4 says, determine the mass of sodium nitrate produced when 0.73 grams of nickel 2 nitrate reacts with sodium hydroxide according to the following equation. So the equation written below there is nickel nitrate plus a coefficient of 2 sodium hydroxide produces nickel hydroxide plus 2 sodium nitrate. So had to squeeze it in there, but we got it in. The question is asking, determine the mass of sodium nitrate produced. So sodium nitrate's in my last column here. And since that's a produced value in my BCA chart down here, that's going to be this box here at the end that I'm looking for. So how much of that's produced when 0.73 grams of nickel 2 nitrate reacts? So 0.73 grams of nickel nitrate here. Now, nickel nitrate has a molecular, so this value cannot go on the table again, remember. Only values that are in moles can go on the table, so I got to use a conversion. Again, the conversion is 183 grams to 1 mole. And so that gives me 0.004 moles. So this is the value I'm going to put into my chart. Before value, change value, after value is 0. Okay, this is the one that's in excess here. And so we're trying to solve for the relationship between nickel nitrate and sodium nitrate. Now the relationship is a 1 to 2 ratio. So that means this change value here is going to be 0.008, which yields 0.008 moles. So now this has got to be changed to, because the question's asking for it in grams, so I'm going to go to the next page here, 0.008 mole, converting it to 1 mole of this, and this is sodium nitrate. That weighs 85 grams, and we get 0.68 grams. So that's our final answer here. There's no percentage yield or anything like that for this one yet. So that's question 4. Question 6. Question 6 says, when hydrochloric acid is added to sodium hydrogen carbonate, water, aqueous sodium chloride, and carbon dioxide gas are the products. What is the percent yield if 4.68 grams of carbon dioxide are collected when 10 grams of sodium hydrogen carbonate reacts with excess HCl? So there's a lot of stuff going on in this. The first thing you want to do, of course, is write the equation. So the equation that we have is HCl plus sodium hydrogen carbonate is going to yield water plus salt plus CO2. Now, if you are following along here, this is the exact same equation, same lab that we did as part of lab 2. Okay, and we were solving for salt. So, the question here now is asking, when hydrochloric acid is added, what is the percent yield? So we're going to be looking for, I'm going to go to the next page here, we're going to be looking for percentage yield, which is our equal to our actual over our theoretical value. Okay, remember the theoretical value comes from the chart. If 4.68 grams of carbon dioxide are collected, when 10 grams of sodium hydrogen carbonate reacts with excess HCl. So this excess part is the key. We're going to go back. So my BCA chart, what I can already mark is that this is an excess. So this one's going to be my limiting reactant. In the question it states that 10 grams of that is reacted. So this is going to be the part that goes into my percentage yield. So this is the actual value that's collected, so that will go here. Now we need to find the theoretical value from what we are given. So in terms of the chart that we did in class today, we were given a substance we'll call A. We were given that in a mass. We're going to convert that first using the molar mass into moles of A. We're going to use the mole ratio to go to moles of B. And lastly, we're going to use the molar mass again to go to the mass of B. So 3 steps to this. And remember, this region here is in your BCA chart. Okay, we have to have those things in moles. So let's go back to the previous slide here. Let's convert this into moles so we can put it into our chart. So sodium hydrogen carbonate has a weight of 84 grams in 1 mole. So converting that, I get 0.119 moles. I'm going to put that into my chart. 0.119, and luckily this whole equation is a 1 to 1 to 1 to 1 to 1 ratio. So in terms of all the values are going to be 0.119, 0.119, 0.119. Okay, and we're looking at CO2. That's the value that we're concerned most about. So 0.119 of CO2 in terms of moles, 1 mole goes on bottom, and the weight of carbon dioxide is 44 grams. So this gives me a theoretical value of 5.24. So now I want to take this value, put it into my percentage yield. This is kind of getting messy at this point, but we have 4.68 over 5.24. Okay, and that gives us roughly 89.3% yield. Okay, question 8. Question 8 is about the hardest one that I can give you here. So here's how it reads. Zinc sulfide and oxygen gas react to form zinc oxide and sulfur dioxide. Determine the amount of zinc oxide that should be produced in reaction between 46.5 grams of zinc sulfide and 13.3 grams of oxygen. What is the mass of the excess reactant? Okay, so there's lots of parts to this. The only thing I didn't put in here was percentage yield. So first let's start with the equation. Again, zinc sulfide reacts with oxygen gas to produce zinc oxide plus sulfur dioxide. Now balancing this, I'm going to put the balance part of this in red here. So if we went through and balanced this all out, we would get a 2,322 mole ratio for our equation. Okay, now we have two starting reactants here. And so this is the hard part. We have to determine which one is limiting and which one is in excess. So in the question it states that there's 46.5 grams of zinc sulfide and there's 13.3 grams of oxygen gas. Okay, so let's convert these to moles so we can put them into our chart. So we put them into our chart here to get our mole value. So zinc sulfide weighs 97.5 grams in 1 mole. So our value for this would be 0.477. For oxygen, it's 32 grams in 1 mole. And so this value is going to give us 0.416 moles. So these are both mole values now. So what we have to do really in this equation is do this twice. Okay, we have to determine which of these values is greater. And this one should be not fairly obvious, but let's see how we go through with this. So we're going to switch over to a different color here to put these values in. So zinc sulfide is 0.477. Oxygen is 0.416. I'm going to do the different ones in different colors here. How about that? So this is 0.416. So what I need to do is I need to take this value and run it through the whole chart once to get my product. And it's determining the amount of zinc oxide. So I'm looking for this chart down here. Now I'm going to put one in purple. I'm going to put one back into this blue here. So I'm going to do this twice now. I'm going to do the blue one first since I'm in that color right now. And so the ratio of this is 2 to 2. So what that means is that this value would be 0.477 if I used the zinc sulfide. Now, in terms of the purple one, I have to take 0.416 and change it over. So this is going to be a 2/3 value, which is 0.277. So of these two, one is limiting, one is excess. The limiting one is in the purple. That's oxygen. The excess one is the blue one, zinc sulfide. So what I need to do now is I'm going to subtract. I'm going to be adding 0.277 here because this is the one that we're using, which also means I'm going to be subtracting 0.277 of here because the mole ratios are the same. So this value ends up being 0.200, and this is going to be my excess part, how much is left over. Okay, this is going to go to 0. That's going to be all used up. And this one we don't really care about for this question anyway. So, at this point, we can go two different ways. Determine the amount of zinc oxide produced. So let's start with this value here. 0.277 moles of zinc oxide. Convert that to grams. 1 mole of this substance is 81.4 grams. And so that gives us 22.5 grams of zinc oxide. There's our value. That's our, of course, the theory value. Going back here, this is our excess reactant, 0.20. 0.200 moles of zinc sulfide. So again, we got to convert that back now. So 1 mole of this weighs 97.5 grams. So this gives us a value of 19.5 grams that are left over. Okay, if you think back, we started with the original question started with 46.5 grams. Whoa, don't know what happened there. 46.5 grams in the original. This is how much is left over. So we could subtract, figure out exactly how much is used if we wanted to also. So that's going to conclude this. It's been long enough. Go ahead and rewatch it if you need to. Again, if you are looking for worksheet 4, that is on the website. And bring in any questions to class tomorrow.